So today we are going to solve few problems, mathematical problems related to Bohr's theory. And the first one is calculate the energy of an electron in the second orbit of a hydrogen atom. So we have to find the energy of the hydrogen atom in the second orbit, that is n equal to 2. Now we know the expression of energy in nth orbit, that is En, is equal to minus m z square e to the power 4 divided by 8 epsilon 0 square in h square n square. Now for hydrogen atom, Z is equal to 1. So Z equal to 1, that is atomic number. So this is equal to minus m e to the power 4 divided by 8 epsilon 0 square h square into 1 by n square. If we write n square like this, now we know that m is the mass of the electron, E is the charge of the electron, epsilon 0 is the permittivity of free space, and h is the Planck constant. If we put all the values of these constant and convert the joule into electron volt, then we can write this as minus 13.6 divided by n square in electron volt. So when we will put the values of m, e, 8, epsilon 0 and h and convert this into electron volt, then we will get this expression En equal to minus 13.6 by n square electron volt. Now here we have to find the energy of an electron in the second orbit, that is n equal to 2. So we put n equal to 2 in this expression and we will get the E2, that is minus 13.6 divided by 2 square, that is 4 electron volt. So this is equal to minus 3.4 electron volt. So the energy of an electron in the second orbit of a hydrogen atom is minus 3.4 electron volt. Now move on to the next question. Here it says calculate the radius of the third orbit n equal to 3 of a hydrogen atom. So here we have to find the radius. Now we know the expression of the radius, that is Rn is equal to epsilon 0 n square h square divided by pi m z e square. Here again this is hydrogen atom, so z equal to 1, so z is equal to 1. So this expression looks like epsilon 0 n h square divided by pi m e square and the n square. Here also if we put the epsilon 0, the values of epsilon 0, h, pi, m, e and put n equal to 1 for the first Bohr orbit, then we will get R1 as 0.529 angstrom, 0.529 angstrom for n equal to 1. And if we put all this value of epsilon 0, h, pi, m, e, that is epsilon 0 is 8.854 into 10 to the power minus 12, h is the Planck constant 6.626 into 10 to the power minus 34, pi is the value of 22 by 7, m is the mass of the electron 9.1 into 10 to the power minus 31 kg, and e is the charge of the electron 1.6 into 10 to the power minus charge of the electron 1.6 into 10 to the minus 19 coulomb. Now for n equal to 3, that is for n equal to 3, R3 will be n square R1, so this value is R1, so n square R1, so n square is 9 R1, so 9, this value is R1 into n square, that is 3 into 3, 9, 3 square 9, so 9 into 0.529 angstrom. and the calculated value will be 4.761 angstrom. Now the next question. Here it says the calculate the wavelength of light emitted when an electron in a hydrogen atom transitions from the third orbit to the second orbit. So when an electron jumps from n = 3 orbit to n = 2 orbit, if an electron comes from n = 3 to n = 2, then the emitted photon, then what will be the frequency, what will be the wavelength? Here we have to find the wavelength. So what will be the wavelength of the emitted photon when an electron makes a transition from n = 3 to n = 2? Now we know the energy difference between the two orbits, that is delta E. The energy difference between the two orbits is E3 minus E2. So E3 is minus 13.6 electron volt by 3 square, that is 9, minus, and E2 is minus 13.6 divided by 2 square, that is 4 electron volt. So this is equal to minus 1.51 minus a plus 3.4, and this is equal to 1.89 electron volt. Now if the frequency of the light is nu, then the energy of the light is h nu. So this h nu is equal to 1.89 electron volt. So if we convert the electron volt into joule, that is 1.6 into 10 to the power minus 19 joule. 1.89 electron volt equal to 1.89 into 1.6 into 10 to the power minus 19 joule. Now nu is c by lambda, so h c by lambda is equal to this 1.89 into 1.6 into 10 to the power minus 19 joule, or lambda is equal to hc by delta E. So h is 6.626 into 10 to the power minus 34. C is the velocity of speed of light, 3 into 10 to the power 8 divided by delta is 1.89 into 1.6 into 10 to the power minus 19. If you calculate these values, then you will get this is equal to approximate equal to 657 nanometer. So 1 nanometer is 10 to the power minus 9 meters. So if we convert meter into nanometer, then we will get 657 nanometer. The next question, very similar question. Calculate the frequency of light emitted when an electron in a hydrogen atom transitions from the second orbit to the first orbit. So here the electron transitions from n = 2 to n = 1. When an electron comes from 2 to 1, then it will emit a photon of frequency nu, then the energy will be h nu. So here also the energy difference between the two levels, that is delta E, is E2 minus E1. So E2 is minus 13.6 by n square, n is 2, so 4 minus 13.6 divided by 1 square in electron volt, and if we calculate this, then we will get the value 10.2. This is equal to 10.2 electron volt. So delta E is 10.2. Now the frequency, if the frequency of the emitted photon is nu, then the energy delta E is equal to h nu. This energy difference will be the energy of the photon. So nu is equal to delta E divided by h. So delta E is 10.2 electron volt. 1 electron volt is 1.6 into 10 to the power minus 19 joule, and the value of h is 6.626 into 10 to the power minus 34 joule second. Now if we calculate this value, then it will be like 2.47 into 10 to the power 15 Hertz. So the frequency of the emitted photon will be 2.47 into 10 to the power 15 Hertz. And the last question, is calculate the velocity of an electron in the first orbit of a hydrogen atom. Now we know, here we have to find the velocity of an electron in the first Bohr orbit. Now we know that the Bohr's theory, from Bohr's theory we know that mvr is equal to nh by 2 pi. Now for n equal to 1, mvr is equal to h by 2 pi. For the first Bohr orbit, n equal to 1. So v is equal to h by 2 pi mr. Now we know the value of h, that is 6.626 into 10 to the power minus 34 joule second divided by 2 into 3.14. m is the mass of the electron, 9.1 into 10 to the power minus 31 kg, and r is the radius of the first Bohr orbit because n equal to 1, and we know that the value is 0.529 angstrom. 0.529 angstrom, and angstrom is 10 to the power minus 10 meter. Now if we calculate all these values, then this will approximately give 2.19 into 10 to the power 6. So if we calculate all these values, then it will give value like this at 2.19 into 10 to the power 6 meter per second. The unit of velocity is meter per second. So thank you.